Well, welcome back, guys. This is episode 3 of Arboretum Bytes
On YouTube?
on YouTube. So, we were going to talk about two topics. So, sort of the podcast can be divided into two sections. The first section, we're going to talk about how to actually get into programming and why you need to learn how to program and what's the point and just all the nitty-gritty details. And the second half, we'll talk about what we sort of missed in our own curriculum and what we wish that we were more exposed to these specific topics that we're going to talk about during our curriculum.
Yeah, I mean, so far, obviously,
So
because
far.
we're still in the second year.
Let me just sort of give some background. I think we finished all of the lower division courses.
Yes, all lower.
So
lower division.
we sort of understand. So basically, lower division is the core concepts. So when we say what we wish we were taught, we're talking about what we wish was taught in the core concept classes.
Okay, so basically lower division.
Division stuff.
Like when people are starting off like those courses, so first and second year.
Yeah.
So yeah.
Okay. So let's get into it. So let's say you're sitting on the computer, and you've probably heard this many times. Everything on your computer is a program. You should learn how to program because it's useful to you. Blah blah blah. But why exactly? So the thing about programming is, in essence, it's automation. You tell the computer to do specific tasks for you over a period of time. That's what programming is. You want the computer to take care of you or to take care of your tasks. And then rather than you having to note stuff down or calculate or analyze or you tell the computer to do it for you, and that saves you time, energy, and it's a lot of fun. It's a hobby for some people to actually program. So to give you an example, what can you do? Let's say you wanted to get all the tweets from a specific person and you wanted to sort of make a collage out of it. You can do that with programming. Yeah. Whereas if you were to do it manually, you have to go on Twitter, go through all their timeline tweets, write it down,
print them out, and
write them down, style them, do lots of things. So, and that's all. And with that, you can sort of take it. You can sort of move on to different fields. You can bring computer science to different fields. I remember in the first episode we talked about how computer science is changing sports and things. It's this exact thing. Yeah. There are many tedious tasks in every industry, and if you can automate them.
In the sense, automation is supposed to just make our life easier in certain aspects, right? Like if you go back before people were, I guess, programming, or automation and technology was at the level that it is today. Like if someone wanted to make a list of something, right? Mm-hmm. They'd write it in a notebook or post-it note or whatever, right? And they'd have to carry that with them everywhere. But now, if you create an app, for example.
An app. I'll just go really, really basic. App means application on your phone. I think most people know. Just for the very few, the 0.1000%.
Yeah. So yeah, you can write an app that.
I just said 0.1%, but whatever.
Yeah, you can write an app that like Wunderlist or like Microsoft To Do, something similar, right? Mm-hmm. In terms of that helps you because you can go anywhere and you can connect to the cloud and it has all your stuff there, right? So programming is anything that program is I feel like programming is something that it gives you that creative outlet,
exactly,
without it being art, I guess.
It is art in a way.
Yeah, I mean, I guess what I meant is you're not drawing something, you're not painting something, right? You're doing something pretty mathematical, right? But there's a lot of numbers and stuff, right? That's why math is important for computer science. But at the same time, you're designing something, you're designing an algorithm or implementing it if it's something that's given,
And from there we can lead on to the different paths you can take. So if you want to go into you're interested in web design, you like making websites. If you're interested in making websites, you would sort of research things called front-end technologies, which are basically programming. So first we need to go into the concept of what a stack is. So a stack is basically complementing programming languages. So you program in languages like Python, and so those are your instruction sets. These are the way how you send instructions to the computer. And different groups of languages can achieve one unified goal. And in this case, front end, which is everything you see when you open.
What a user sees, with your thing when you see with your own eyes. I see that this box on this website is red. Mm-hmm. I see this text, right? That's all front end development, how they got that text on the screen, right?
Then you would move on to things like back-end technologies, which are the think of it like the brain behind the website. You need to have some sort of like, languages like Java or like Python.
Yeah. So like I think like a good example of like where backend comes in is, suppose a website has certain data that's always being updated. For example, like I don't know, a weather app, right? It's constantly up. Like if you check right now and you check in 15 minutes, it's likely that the Fahrenheit or Celsius or whatever is going to be different, right? So you're getting that information from a database
or another database that you call on another
Yeah.
person's database and they call another.
Yeah,
That's
it's
how
all
it
back-end
spreads out,
stuff.
yeah.
But like what you're actually seeing on the screen, that's the front-end stuff.
Mhm.
So the beautiful thing about it actually is that like you can have front-end and back-end working together, and a lot of times they don't really need to know what's like the front-end doesn't need to know where that data is coming from. Their
Exactly,
job is
yeah.
to sort of just put it out there. Whatever the back-end is, the back-end developers are getting the information. The front-end are just taking whatever they get without worrying about it. And displaying it however so they choose.
And then we have app development, which you can talk more about because you have more experience with that.
Yeah, app development I think I think app development's a good example of like both front end and back end. Like I was saying, for example, like with a weather app, the front end is very important, right? You don't want to make an app that's like ugly, right? Because like then nobody's gonna want to use it, right? But at the same time, suppose you have like the most beautiful looking app, right? But it takes forever to log in with your account, right? That's all back-end stuff related to like token authentication and like all the stuff related to logging in a user. That's all like back-end stuff, like getting.
And think of a token as like a unique ID that they give you. So every person has a unique ID. Think of it as a key and it's like a door. You need to show them your exact correct token for them to let you in.
It's not as simple as just like, that you check that the username matches and the password
No, these
matches.
are like complicated strings. Strings as in like different combinations of letters and numbers.
Yeah.
So this is another thing. We've told you like big ideas in like programming, but there's like you can specify you want to go toward more the computer security side. They're like subfields and even more subfields. So it's a really expansive thing. But I would implore you to research more on your own time. There's only so much you can tell someone in a 10-minute podcast. But I hope at least this sort of like shows you what like possibilities are in a very hand-wavy manner. But like let's go on to what we think we missed in our curriculum.
I think that like a lot of the curriculum that I've noticed is it's heavy on programming, obviously, because it's like one of the most important skills
It's too much math
to start with. And yeah, I think if you're not in a software engineering major, there's a lot of math. I'm thinking like discrete math, which is like Boolean algebra math. You can kind of think
Theoretical
of proofs and like
theory of computation, discrete math, statistics and probability,
but
calculus.
That stuff is important as well, right? Because
Yes, it is surprising, and specifically if you're like into the cool kid on the block, which is AI.
Yeah. Then linear.
Oh my God,
stuff.
that is so much math. It is basically statistics.
Yeah, I mean, or like data science is basically.
It is statistics.
Stats.
Yeah.
It's like
stats is a huge thing, and like in linear algebra. So you learn about things called regressions. Those are the one thing I liked about my linear algebra class when they taught, because that was pretty fun to actually find those things. But you'll learn more about those, or you can research them on your own time. But I think what we're missing overall is like a class which we've found out like a couple of weeks ago that they are trying to implement this class at UC Davis, which is the things that we missed, and like it's based on an MIT class,
which is a really good institution to base classes off of. If they're doing something, then might be a good idea to.
But it's no UC Davis, come on. So what I'm trying to say is like there are things that we wish we had, and one of those was like more like of a introduction to like not programming technologies, but like productivity technologies that actually help you code.
Yeah, for example, like Git and GitHub, right? Like version control, because a lot of times you write code that's really bad and you need to go back to a prior stage, right? And you don't want to waste time. Just like how programming is for automation, making our life easier, right? Like that's the purpose we're programming, right? We should also learn the programs that are already there to help us make programs in a more efficient manner, right? You don't want to waste time. Like even think about like if they gave like a Linux, like if they explained like Linux and like terminal and
Right now, it's like, oh, get in the car. We gotta go right now, kid. It's like, but no, I don't understand what MKD. It doesn't matter. We have an assignment due. Let's go.
yeah, if they taught those things, you can make your life like Bash, for example, right?
Bash is very useful.
Like it's so useful for like because you waste a lot of time like just putting in the same command like over and over again to run your program, for example. But like you could just write a script in Bash that'll do it for you, and you only have to enter like a few words, and it just does so much stuff for you, right? If you write it once, and it does it all for you. Or if they teach like debugging, like in that's an important skill because if you can't figure out what's wrong with your code, the first thing you go to is a debugger. But if you don't know how to use one properly, then
and things
that
like
sucks.
tools like Valgrind, which I think they exposed us to it.
Yeah, but not really like that much.
But like you should do it, but I'm not gonna like force you. The professor's like, I'm not gonna force you.
And
but like,
to be honest, like if they're not, I think very few people will actually do it unless like you're.
Yeah, people like me were idiots, but then when we started using Valgrind, that was a game changer. Valgrind is amazing, and people who know what Valgrind is basically something that checks for like memory leaks and if you take a C or C++ class, I really recommend that you check out Valgrind.
Yeah, I haven't really used Valgrind, to be honest.
Valgrind is the best thing.
So I have I downloaded it and like installed it, but I never actually ended up using it. So definitely when we get to like those classes that require C, I'm gonna need to.
No,
to
Valgrind is.
But
is
I think
great.
number one thing that you should know how to do well is Git and GitHub. I think because version control is so useful because you're bound to make a mistake and you're bound to want to go back to something old. Like I'm not talking about just like I mean a lot of people can just learn add this, commit this, right? But like learning about like branches, right? And like you can merge merging and making branches at least. I guess rebasing is not that important, but making branches and merging.
And actually, like good technique to use it, not just like I do. I just wing it. No, you should actually learn what the best proper techniques are.
It's an investment. That's why I feel like if they have a class on it, which they're planning on doing, is really good because then it forces you to learn it. Because otherwise, there's a lot of time you're gonna put on your own, but it's worth it.
One thing that they're not adding is, which I would really love, is like a pure design class meant for CS majors. And when I mean design, I mean actually like drawing the front end, like making like mock-ups and stuff. Like I think there's a UI UX class in the design department, but like for CS majors, like if you want to go into the front end, they teach you how to make like mock-ups, website mock-ups, maybe 3D modeling a bit. If you want to go, I know there's a game design class, but it's like a special class. They'll show up sometimes and sometimes not. You have to be in the right place, right time for that. But I really wish there was more of a creative twist to our classes than there is right now. Now there's more of like a math flavor. It's like a really musky, disgusting taste. But
I like math, so
I hate math. But I think this gives you more or less a good like idea of what we wish we were taught in college, in our early like year of college, and what you should like start planning right now if you do like want to get into this. If you're a high school student, maybe start right now. If you're a senior, yes. If you're in elementary school, please go back. No, you don't need to listen to this. I don't know why you're listening to
Go
this.
and
enjoy your life. But if you're a college student, I hope this gives you more incentive to actually look into this stuff that we talked about. And I think we'll sign off right now. We went over our 10-minute limit, but sometimes you just got to get the message across.
Yeah.
Okay then.
All right.
Thank you, everyone.
See you guys later.
Yeah.